This video is going to be on section 9.1, null and alternative hypotheses. By the end of the chapter, you should be able to differentiate between type 1 and type 2 errors, describe hypothesis testing in general and in practice, conduct and interpret hypothesis tests for a single population mean where we know the population standard deviation, conduct and interpret hypothesis tests for a single population mean when we don't know the population standard deviation, conduct and interpret hypothesis tests for a single population proportion. So people, organizations, corporations, etc., make claims all the time. For example, a car dealer can advertise that its new small truck gets 35 miles per gallon on average. A tutoring service claims that its method of tutoring helps 90% of its students get an A or a B. A company says that women managers in their company earn an average of $60,000 per year. Statisticians make statistical inferences and decisions about claims based on samples taken from the population. So this process is called hypothesis testing. This involves collecting data from a sample and evaluating that data. Then we decide if there is sufficient evidence based upon analyses of the data to reject the null hypothesis. So hypothesis testing consists of two contradictory hypotheses or statements, a decision based on the data, and a conclusion. So to perform a hypothesis test, a statistician will set up two contradictory hypotheses. They have to say opposite things. Collect sample data. In our problems, examples, and stuff like that, you'll be given the data, but for your project, you're going to be collecting the data. We're going to determine the correct distribution, the normal or student's t distribution if you're doing it for means, and then for proportions, it's just the normal distribution, and to perform the hypothesis test. And analyze sample data by performing the calculations that ultimately allow us to reject or decline to reject the null hypothesis. And again, this is one of those situations in statistics where we're like kind of specific about the wording that we use. So we reject the null hypothesis or we decline to reject the null hypothesis. And we'll get into that. And then we make a decision based on that and we write a meaningful conclusion. So a hypothesis is a testable statement about the relationship between two or more variables or a proposed explanation for some observed phenomenon. For us, it is a statement about the value of a population parameter. The two contradictory or opposing hypotheses in hypothesis testing are, so we call this H sub 0 or H naught, and that's the null hypothesis. And this is a statement about the population that either is believed to be true or it's put forth as an argument unless it can be shown to be incorrect beyond a reasonable doubt. H sub 0 is the alternative hypothesis, and it's a claim about the population that is contradictory to H naught, our null hypothesis, and what we conclude when we reject H naught, our null hypothesis. This is usually or often what the researcher is trying to prove. So in this section, we're going to be writing null and alternative hypotheses. And so a lot of times H sub A, the alternative hypothesis, is what we're actually trying to show. And then we can write the null hypothesis based on that. Since these are contradictory, we examine evidence to decide if we have enough evidence to reject the null hypothesis or not. And that evidence is our sample data. So the null and alternative hypotheses are stated together. The null hypothesis, H naught, contains the equal sign in some form. So either greater than or equal to, less than or equal to, or just equal to. And the alternative hypothesis, H sub A, never contains any form of the equal sign. So, here it says example, no greater than or equal to, less than or equal to, or equal to. So what you're going to see is the alternative hypothesis is less than, greater than, or not equal to. So here we have a little table that shows some of these options. So here in this top part, this is a two-tailed test. The null hypothesis says the mean mu equals some value k, and the alternative hypothesis says the mean does not equal k. So that's two-tailed. It could be greater than or less than, it just doesn't equal k. In a right-tailed test, our null hypothesis can have mu, our mean, equal k, or it could have that our mean mu is less than or equal to k. And then the alternative hypothesis is that mu, our mean, is greater than k. So, and then again, that's right-tailed. So I'm probably opposite of what you're seeing, but it goes out to the right. Left-tailed, our null hypothesis is our mean equals k, or our mean is greater than or equal to k, so that our alternative hypothesis is that our mean mu is less than k. And see how the less than points to the left? That can help you with those names. So our first example, example 9.2, we want to test whether the mean GPA of students in American colleges is different from 2.0 out of a 4.0 scale. So our null and alternative hypotheses are H naught, the null hypothesis, mu, our mean, equals 2.0. And then our alternative hypothesis, H sub A, is that the mean mu does not equal 2.0. So see, it says we want to test whether the mean GPA of students in American college is different from 2.0. So we don't care if it's less than or greater than, we just don't want it to equal 2.0. And these two hypotheses contradict each other. They're mutually exclusive. They can't happen at the same time. So sometimes maybe you might write your alternative hypothesis first and then your null hypothesis. Sometimes you'll write your null hypothesis and then your alternative hypothesis. So here's a try it 9.2. We want to test whether the mean height of 8th graders is 66 inches. State the null and alternative hypotheses. So again, be careful when you're reading the problems and think about what the words mean. Is 66, that's an equal to. All right, so our null hypothesis is going to be equals 66. So H naught is mu equals 66 because our null hypothesis has to have the equal part in it. And then our alternative statement hypothesis is mu does not equal 66. Again, we don't care if it's less than or greater than, we just want to know if it is 66 or is not 66. Try it 9.3. We want to test if it takes fewer than 45 minutes to teach a lesson plan. State the null and alternative hypotheses. So we're going to test if it takes fewer than 45 minutes. What does fewer mean? It means less than. So in this case, our null hypothesis is going to be our mean mu is greater than or equal to 45, because our alternative hypothesis is that our mean is less than 45. So this would be a case where you might write the alternative first. So fewer than 45 would be less than 45. And then you can write your null hypothesis based off of that. Try it 9.4. On a state driver's test, about 40% pass the test on the first try. We want to test if more than 40% pass on the first try. State the null and alternative hypotheses. Sometimes I think it's tricky to know, like, if your null hypothesis is going to have a greater than or equal to, or what you're going to do. And so read the problems carefully, and just decipher the words, right? So here it says about 40%. So that is kind of an equal to 40% statement. And we want to test if more than 40%. So again, the alternative hypothesis can't ever have an equal sign in it. So our alternative hypothesis is going to be greater than 40%, which makes our null, and like I said, about 40%, that's equal to. And so this time we're not testing for a mean, we're talking about a proportion, so a proportion can be written as a percent or a decimal. So here our null hypothesis is P equals 0.40, and the alternative is greater than 0.40, because we want to test if more than 40% pass on the first try. So that's it for 9.1 on null and alternative hypotheses.